welcome back to AGT STEM. Today we're going to be watching a video about neodymium. So, without further ado, let's hop to it.
Yeah, so neodymium is one of my favourite F elements to work with. When you use it in compounds and you dissolve it, often you get beautiful blue solutions from it. Sometimes they're green as well, but often I've found that if the concentration of the solution makes a really big difference to the colour of these solutions. So you may have a compound which appears to be red, but actually as you dilute it down, eventually it ends up being blue, which is really pretty. And sometimes if you cannula it from one flask to another and you can see through the cannula, you can see it changing colour as it goes through the cannula and then drops into the next solution again.
So neodymium is one of the rare earths, and it has a number of quite important applications. One of the, my favourite is in lasers. It's used, for example, in this laser pointer, and if you point the laser, it makes this rather nice bright green colour.
A little known use of neodymium is that the size and strength of volcanic eruptions can actually be judged from the composition of neodymium isotopes.
So neodymium can tell you how strong volcano eruptions are, which I think that's pretty interesting. I didn't know that there was an element that could do that.
Which are present.
The first laser pointers were red, they didn't use neodymium, and the green ones have become really quite fashionable among lecturers. So the way this works is that inside here there is a small crystal of so-called neodymium YAG. These are some of the neodymium atoms that are isolated in a glass that contains yttrium and aluminium together to form so-called, the G is for garnet, which describes the structure of the solid. And if you excite this, the neodymium atoms can emit light in the infrared, like heat rays, you can't see them. And then further up here, there's another crystal which turns this infrared light into green light. So the green light comes out at the end.
And also, when neodymium is combined with iron and boron, it can form a type of magnet which we call a permanent magnet, and it is extremely strong, one of the strongest that we actually know of.
In order to get this doubling from the infrared to the green to work, you need to have pulses of light. So green lasers, although to the eye look as if they're continuous, are actually very rapid pulses which are very intense, which is why these pointers are quite dangerous if you point them the wrong direction in a lecture. And because I wave my hands so much, I never use these in lectures. But I know that you, the cameraman, have also used used neodymium, because neodymium is element number 60, and the cameraman's future mother-in-law was 60 a few days ago, and so we provided a sample of neodymium, element 60, for him to present to her as a birthday present.
Happy birthday, Marion.
What a sweet birthday present. Element 60 for being 60. Thank you so much for watching, and we'll see you next time. Stay smart. Bye!